Mathematics Education 2023A, and today we will present our STEM project entitled Water Sprinklers for Plants.
An eco-friendly and efficient water spray system to help farmers water their plants.
This project was developed by Team 1 from Mathematics Education 2023A. Hello, I am Silviana Dwi Isnaini with realized digit number 131.
And I am Azzahra Cahyaning with the last three digit number 142.
Hi, I'm Santi Kurniasari with the last three digit number is 245.
This STEM project was designed for 9th grade students at SMP Negeri 2 Taman, located in Sidoarjo, East Java. The project applied a project-based learning model with a solution-centric approach and followed the engineering design process. It also supports several sustainable development goals, specifically SDGs number 2, Zero Hunger, SDGs number 6, Clean Water and Sanitation, and SDGs number 12, Responsible Consumption and Production.
We adopted a project-based learning model which emphasized hands-on experience. Students design and build an automatic sprinkle system that operates without sensors or remote control. This model helps develop critical thinking, engages teamwork, and allows students to apply STEM concepts to real-world agricultural challenges. In this project, we use solution-centric approach, which starts by introducing a potential solution early on. Students were presented with the idea of an automatic sprinkle, adapted it to real conditions, analyzed its strengths and limitations, and linked the system back to relevant science and math concepts.
The main objective of this project are to help students understand the principle of fluid pressure and momentum conservation, design and build a working prototype of a water sprayer using basic materials, model the spray ring using a quadratic function, test the system performed based on various parameters, and present the result as a real-world STEM-based solution. This project integrates four STEM disciplines. The first, science, by observing liquid pressure and analyzing the momentum when two water streams collide. The second, technology, through the use of design software and blueprints. And the third, engineering, by applying the engineering design process to build the water sprayer. And the last, mathematics, through the use of quadratic function to model water spray distance and calculate the area covered, as well as determining appropriate pipe length.
The project contributes to agricultural productivity by ensuring water is distributed evenly, reducing waste, and supporting food security. It also promotes sustainable water usage and reduces plastic waste by repurposing used materials like bottles and old pipes.
The engineering process in this project starts from the ask stage, where we identified farmers' problem in manually watering the fields. We asked what are the difficulties, is there an automatic and efficient watering system, how much spray coverage is needed. Then into the research stage, we observe how a simple sprayer works, studying water pressure, spray direction, and water flow. We also explored commonly used spray systems such as garden sprinklers. Next comes the imagine stage, where we start to design a solution idea. We envisioned an automated sprayers that saves water, use recycled materials, and can evenly cover the plant area. After that, we went into the plan stage, designing a spray system using old bottles, pebbles, and a simple pressure system. We made design drawing and prepare the materials. Then we create or build a prototype based on the plan. We assembled the pipes connection, the sprayers, and documented the entire manufacturing process. After the tool was finished, we did the test to test the performance of the tool. We measured the spray distance, pressure, and water distribution efficiency, we compared the result with mathematical calculation such as the quadratic function to determine the spray range. And finally, in the improved state, we evaluate the tool if the water distribution is uniform. We revise the design or change the material. We also note development ideas such as an energy efficient version, a portable model, or a drip irrigation system.
The teacher asked one student to lead the prayer, then posed several questions to the class about the impact of uneven manual watering and how to improve the efficiency of water distribution for plants. After that, the teacher explained the learning objective for the day and organized the students into groups. The teacher presents a video about manual watering and sprinklers, then distributes the learner worksheet containing a problem related to manual watering. The teacher assists and guides students if they encounter any difficult. Group representatives are asked to share their ideas about their water sprinkler design, followed by a class discussion and the challenge of implementing those designs. The teacher instructs each group to discuss their water sprinkler design and guides them to gather information from various sources to support their ideas. The teacher then assists students in the design process, which include the following steps: creating the model, identifying the necessary tools and materials based on the design, and calculating the cost of production. The teacher informs the student that their water sprinkler design will be tested based on the criteria they have developed. The teacher observes the student during their group discussion and then asks each group to present their water sprinkler design. Finally, the teacher leads a class discussion to reflect on the presentation and ideas shared. The teacher guides the student in creating a schedule for building their water sprinkler and setting targets to be achieved. The teacher also informs the student about the tools and materials they need to prepare for the next session. The teacher reviews the activities conducted during the session and guides the student in reflection on what they have learned and accomplished. Finally, the teacher asks one of the students to lead the closing prayer.
The teacher greets the students and creates a positive atmosphere in the classroom, for example, by asking how the students are doing. The teacher then asks the students to share the progress of their projects and provides direction or feedback as needed. Teacher guides students in making or assembling the water sprinkler model according to the design and procedures that have been planned. Teacher asks each group to present the water sprinkler model they have made. Teacher guides the class discussion on the water sprinkler model made by the students. The teacher guides the students to test the water sprinkler following the steps outlined in the worksheet. The teacher then asks the students to record the test results as indicators of the success or failure of the water sprinkler. Finally, the teacher requests that each group take pictures or videos of the water sprinkler they have created. The teacher asks each group to conduct an evaluation by filling in the evaluation sheet for the water sprinkler they have created. The teacher then asks the students to follow up on the evaluation results by making improvements or, if necessary, redesigning their projects to find the best solution. Finally, the teacher asks the students to write a project report following the provided report format. The teacher asks each group representative to present the results of their water sprinkler project and share the experience they gained during the manufacturing process. The teacher appreciates the students' work and provides suggestions for further development. Finally, the teacher gives reinforcement on the topic of quadratic function. The teacher reviews the activities that have been completed, and then the teacher and students reflect on the experience. Finally, the teacher asks one of the students to lead the closing prayer.
That's it, the presentation of our group. Thank you for your attention, and we hope this project inspires more creative and sustainable solution in agriculture. See you in the next innovation.
Wassalamualaikum warahmatullahi wabarakatuh. Satu.
Ha.